Hi, everybody. Welcome to the future. Brooklyn 2688. It's great here. The air is clean, the dirt is clean, the graffiti is clean. And I had to find out for myself if the story of the fathers of invention was apocryphal or if they really existed. And I'm glad to say they really do. Got in Rufus's phone booth and came back to check. Bre Pettis and Zack Hoeken. Say it again for me. Hoeken. I have it right, and I keep thinking I've got it wrong. Okay, are pretty much the beginning of the future. Replicators start here. Bre is the founder, and Zack a co-founder of MakerBot, a 3D printer, right? A replicator. It makes things. It turns software into hardware, so to speak. Bre has done a lot of things. I'm going to some of them, not all of them, certainly. He's the founder of MakerBot. I believe he's the founder of NYC Resistor, a Brooklyn collective that does all sorts of cool stuff. You should check it out. We had a great offsite there. He hosts and has hosted Make Magazine's weekly podcast, our weekend projects for Make Magazine, and has been a public school teacher, inspiring people, and probably tons of stuff I don't know about and didn't read about beforehand. Basically, Bre is here to help turn our dreams into reality, and through devices like this. Zack, equally cool, is pretty much committed to making those science fiction futures the present. Zack has collaborative websites. He does a lot of stuff with open source microcontrollers, and once again, and the coolest musical instrument you've ever seen someone wear. You should go check out his blog and see what I'm talking about for yourself. There was one more thing I was going to point out, the historical significance, for where I come from, of MakerBot. The best episode of the Star Trek animated series is when Scotty realizes they're in trouble when the computer builds another computer. And this is pretty much where that starts. Without further ado, Bre Pettis and Zack Hoeken.
Okay, so we're really excited to be here because, what's that?
Bre, raise your hand.
Oh, I'm Bre.
Zack, raise your hand.
Hi, and I'm Zack Hoeken.
So together with our friend Adam, we started MakerBot Industries, and we're going to talk to you a little bit about this today. And then, but that was, first of all, that was a great intro. Thank you very much. And give him a round of applause. Okay, here we go. So, all right, here we go. MakerBot is something that makes things. It's a robot that will make digital designs become physical objects.
Like this.
Here it is in this slide at South. I took it to South by Southwest, and can anybody recognize anybody in this photo? That's R. Stevens in the back and MC Frontalot rocking out with the MakerBot.
So one of the nice things about MakerBots is that they're portable. They're these sort of desktop-shaped machines, and you can pick them up and carry around with you. They fit in Pelican cases, which are really awesome. Here's another shot of it at South by Southwest. We basically just took it from bar to bar to bar, printing out dodecahedrons and shot glasses. And this is Jonathan Colton, who sings lots of awesome songs like Code Monkey.
Alcohol and robotics, great combination. So today we've actually come here to give this talk, and then afterwards we've got a MacGyver team that's gonna 25 folks that are gonna. We're actually gonna build 2 MakerBots later this afternoon. If you're in the neighborhood, feel free to stop by and say hi. We'll be soldering and hacking like crazy until it's done. Oh, here we have a video. Let's get. Oh, let me turn off the Daft Punk here. It's sad, but you know, every once in a while you have to
happen.
Turn off the Daft Punk. Okay.
Bre Pettis here with my friends Marius and Philip, and they're here in New York on a hackcation. They're vacationing and hacking basically 24/7 here at NYC Resistor. And today, something very exciting happened. We got black ABS plastic in the MakerBot store. What's black ABS plastic good for?
Printing evil stuff. The force is strong within this one.
This is 4 times speed. 16 times speed.
And this is actually real time here. Yep.
Yeah, the stepper motors are playing that.
Okay, it's all done. Check it out. It looks good. This is pretty much the ultimate thing to print out on a MakerBot with black ABS. You can check it out. Get your own ABS plastic for your MakerBot, makerbot.com.
I want this battle station operational in 5 minutes.
Yes, sir.
Okay.
So MakerBot is one of those things that I know I've dreamed about for a really long time. Growing up as a kid, reading all sorts of sci-fi, watching all the Star Trek episodes, and seeing this machine that can just build you something, and you say, I want Earl Grey hot, and all of a sudden, boo, and you have the thing there and you can just drink it. So it's nice to finally be an adult and be able to just go after that dream and try and build something that's never really existed before in the form that you want it. And that's how we got here today.
I mean, we were promised flying cars. Why aren't we driving around New York in these? I would wear those clothes just to do that.
We were also promised space colonies. You know, we were going to take our flying cars to the space station, and then we were going to live in outer space, in an orbiting station, or on Mars, or on the moon, or all these cool things. But it just hasn't happened yet.
I mean, how many in the room have a jetpack? Okay, I thought so.
We knew there were at least
We knew
one.
there would be one. Well, we all don't have them yet, and they're a little. You know, we're still dealing with like telephone pole wires and stuff like that. Well, few obstacles on that one.
And last but not least, we were promised through things like Star Trek and other pop culture, a machine that will just, you tell it what to make and it'll make it for you automatically. And it might not be to that point, but as of a few years ago, it's starting to happen. And it's starting to become accessible to people.
1 out of 4 isn't too bad. It's a good start. So here's our team.
This is the team. So these guys are pretty much the founders and the inspiration for MakerBot Industries. So the guy in the middle holding the prototype MakerBot there, he's Dr. Adrian Boyer. Now this guy is sort of like the godfather of open source 3D printing. He's the guy that started the RepRap project, which we're BFFs with. He's a professor over in the UK, and he's just been doing some really cool stuff with 3D printing for a long time.
He's also a seed investor, which is really awesome.
Yeah, he helped us get off the ground, which is good. I'm there on the left, and I've been involved with RepRap for a really long time. I started a non-for-profit called the RepRap Research Foundation to do research into self-replicating open source manufacturing systems. And Bre's been helping me out for years now, building electronics and just hacking and doing all sorts of fun stuff. Then on the right is our friend Adam, who unfortunately still has to work a day job. Soon that will be over. But he's also just a really smart dude that's been helping out for a while. And together, we're MakerBot Industries.
Yeah, it's funny. I started this collective, and I was looking for people to join me at NYC Resistor to find like a clubhouse for geeks. And I met Zach, and he's like, yeah, I'm working on self-replicating robots. And I was like, okay, you're in. So this is the RepRap. This is basically where this idea started from. As Zach mentioned, he started the RepRap Research Foundation. He's actually, the electronics that are on here are actually the same electronics that will work on a RepRap. And the cool thing about it is that it's literally a machine made to make other machines just like it. It's a little bit of a chicken and egg problem, though. If you want a machine that's been made by another machine, you have to have another machine, and it gets a little bit tricky here. The nice thing is that our machine can actually print out all these parts.
So these are our very early prototypes here. On the left, you have the very first one, and on the right, the next one. The nice thing about doing digital fabrication and building objects that are made by machines is that you have this source file that's on your computer, and you basically hit print, and then you can have a prototype. You can look at it, you can shake it around, and make sure that it all fits together and works. It's sort of like hitting F5 when you're doing web development. F5, does it work? Yes, OK. And so these are our prototypes. And
we made these the body is made using a laser cutter. We've got one at NYC Resistor, and we actually teach classes in how to use that because it makes making things, like you said,
awesome.
F5.
It's a laser.
So open source. We're actually trying to out-open anything and everyone. If we've got a digital design file, it's on the internet. We keep our SVN, our Subversion repository is, anybody can go there and get the latest version. It might not work because we put things up there that are prototypes, but if you want to follow along or see what we're doing, we're basically getting everything out there. These are the actual laser cutting files in QCAD, and we've also got all the electronics on the internet. You could literally, if you wanted to have these boards made yourself, you could send them off. If you wanted to do everything yourself, you could do it without us. No big deal. It would actually probably be cheaper to get all the parts from us, but for those people who are diehards, I'm going to do everything myself. Or for those people who just want to see how it works because they want to make a modification or do something special with it, it's all on the internet, so you can just download it and make any changes you like.
The cool thing about being open source is it means that all of those files are there for hacking. So when we designed this machine, we wanted to make the most hackable open source 3D printer out there. You'll notice that it's made mostly of wood. One of the reasons for that is because wood is the easiest material to hack. Like, all of the tools for making holes in it and cutting it are all very common. Most people have a drill or a saw or something of that nature. So we could have done it out of acrylic. The problem is acrylic is really hard to drill into. So it cracks, it shatters, and if you break it, then it's game over. If you break this thing, you can glue it back together. You could have little popsicle stick splints, and it's really easy to just get in there without having to worry about destroying your precious machine. So open source allows us to also share, and sharing is caring.
This is just a simple hack, but the folks at Will Be in Baltic, which is a hackerspace in Boston, got one, and they promptly made it look cooler than ours, which we actually have. We've got to fix that. And they painted theirs black, and then you can see their little build platform has the little caution kind of decoration on it. Very cool. Other people have done things like we lent this bot actually to our friend Charles Pax, and he took it to First Robotics, and he came back with this cool little place where you can rest all your plastic, and it actually hooks into two little holes that were originally there for LEDs, but he's added this really cool thing that I just threw all the plastic off of. Yeah,
it's not very much there. So now we're going to dive into the technical details. We're not going to go super deep because we only have a little bit of time, but if you have technical questions, there's a ton of info on the website. There's sources, and we love answering questions too. So let's just jump right to it.
So when we made this, we decided we wanted it to be big enough to make useful things. And so if you make your hand into a C, and then you make your other hand into a C, and you kind of go like that, that's how big the things are that you can make with this. We told everybody we would make it so that it would be 100 centimeters, or 100 millimeters by 100 millimeters, or a cubic decimeter, and that's what we've got here. This little build basin here is actually 100 centimeters by 100 centimeters. So that gives you an idea of the actual size. It's about, for the imperialists, that's about 4.5 inches.
But it's actually a little bit taller than that. When we set out the design specs, like Bre said, we want to do 100 by 100 by 100. But being the overachievers we are, we decided, well, that's just not big enough. So we found all these little tweaks and hacks and little modifications we could make to the design. And so now it's actually about 130 in the Z-axis, and then about 115 on the X and Y. So you can make objects that are a little bit bigger. And there's probably still a few millimeters or maybe another centimeter in there if you're an aspiring hacker. We have a Hall of Fame on the MakerBot wiki where people can post like the biggest object or the most volume or the most complicated. And so this Empire State Building model is actually the current record holder. It's just a hair under 12 centimeters. So it's 122.
I should also mention we called it the Cupcake CNC because just to give people who maybe don't have a lot of experience with 3D printing, you could make something the size of a cupcake, or you could make a model of somebody actually made a model of a cupcake. So you could actually build a 3D model of a cupcake. And then we also, just for fun, made a frosting extruder so that you could automate the cupcake decorating process. But a cupcake will fit in there as well to give people an idea of the size of stuff. So this is the MakerBot in a Pelican case. It weighs in at 42 pounds. Most of that is actually the Pelican case. Yeah, the TSA is going to look at it. Just tell them up front that it's a friendly robot. That generally helps. It's worked for us so far. Knock on wood.
The MakerBot is also small enough that it'll fit on your desk. So this is the one that I do all my printing on at home, and it sits there on my desk next to my old busted 2D printer, and then I have my computer, and then I have my shiny, nice and varnished MakerBot. And which is really handy because there are commercial ones out there, but these guys are like the mainframes of 3D printing. They're like these big hulking boxes that usually need their own room or like their own corner of a room. And to be able to have a 3D printer that can just fit on your desk it's really awesome. I'm really liking it.
They also cost a lot of money. If you want a commercial built for you 3D printer, you're going to spend minimum $25K. And for a decent one, you're looking at more like $250,000. We're trying to seriously undercut our competition there. Okay, so we're a Brooklyn company. This is our warehouse in Brooklyn, and we ship things out of it. And this is actually the whole team. We have a employee named Ryan, who's awesome, who's our operations manager and makes sure everything gets out. And this is us packing up our first batch of cupcake CNCs to send out into the world.
So here's a photo of all the parts when we were doing the first batch. So up in the upper left-hand corner, we have the laser cut parts for the body and the Z stage. Right next to that on the top is a standard ATX power supply. So in order to build a cheap, hackable, open source 3D printer, we wanted to find parts that are commonly available and cheap. So ATX power supplies really fit that bill pretty nicely. Below that, there's the electronics kits. So right now, they come as little kits that you solder up yourself, which is pretty fun. And we're working on getting those manufactured. That's happening right now, which is really exciting to have that happen. Next to that, to the right, there's the belt and pulley kit. So this is a belt drive system. So there's motors and pulleys that transfer rotational motion into linear motion. And to the top and to the right of that are the small laser cut bits. In the upper right-hand corner, we have a 5-pound roll of ABS plastic, which is enough to keep you printing nonstop for about a month. Below that, inside that box, there are stepper motors. They're kind of heavy, and we put them in the box to protect things. Then you have your cables kit, the hardware burrito, which is just like a giant chunk of awesome metric hardware. There's an XY stage, and then there's the plastruder kit, and you can see the capped-on tape, which is probably the coolest thing in the universe as far as materials go. It's like radiation resistant, and it can handle really high temperatures, and it doesn't even blink. Then there's another tools kit, and then a build base kit.
The whole thing goes together modularly. We wanted it to basically be, you can basically put it together by hand. This is what we call a T-slot. It's basically the way the whole thing goes together. And you stick a nut in this little section right here. We call it a T-slot because it kind of looks like a T. This is sort of an upside-down T. You put a nut in there, and then you put the bolt, and you just twist it in, and the little slot holds the nut in there. So you can just turn it. It goes together. You tighten it down with an Allen wrench, kind of like the thing that you get at IKEA, and it bolts together like that.
Currently, the hardest part of the build is doing the soldering. With modern electronics, all of the good chips only come in surface mount packages, which can be a little bit intimidating, but it's actually not really too hard. Later today, we're going to be doing this, and we'll get to see the magic of solder paste syringes and all sorts of fun stuff like that. But we just do it on a $20 hot plate, and it's really simple. But like I said, these are getting manufactured, so soon the hurdle and the barrier to entry is going to be even lower. So eventually, all you'll need is an Allen key, or, well, you could just buy one out of the box. But it's much more fun to build it yourself, because then you know how everything works, and you can fix it if it breaks.
The other thing is that with SMD soldering, if you say, like, yeah, I SMD soldered that, it actually carries a lot of geek cred. And luckily, it's cool because it's actually pretty simple. But it's a simple way to get pretty awesome cred. Just saying. It takes 2 people to put a weekend to put it together. Today we're going to try and do it with 25 people in 3 hours. We'll see how that goes. We're committed to being here until it's done. And what's inside this one, Zach?
This is an airplane wing. So doing a little model airplane work. So this is a fairly old map of all of the different countries and continents we've shipped to. As of a few weeks ago, we've actually shipped a MakerBot to every continent except for Antarctica. So if anybody knows any polar researchers, we would love to get them a MakerBot so that they can like print out replacement parts without having to call in airdrops, or I don't know how they do that. Yes. So yeah, there's a growing community of people building these things. There's probably about 50 of them now, and they're very active. These people like to build things and post them, and the cool thing is that everybody has the same hardware, so you can easily exchange designs and collaborate and do all that fun stuff that comes with the community.
We don't have a slide for this, but I'm just going to jump in here and mention we also started a site called Thingiverse, which we made all the we started having all these designs, and we were looking for designs of dog heads and other designs, and we didn't find a place where you could find models for 3D objects. And so we made one called Thingiverse, where you can share the designs that you make. And the cool thing is, like, I uploaded a monkey, and then I went to sleep, and when I woke up, my friend had downloaded it, improved it, taken a better picture than I had, and shared it as well.
And that actually happened. It was his friend from Germany. So overnight, his friend had downloaded the design and printed out one faster than you could even have shipped it. So through the magic of the internet, he essentially teleported the object from Brooklyn to Germany, and it was awesome.
So there's a number of different kind of materials that you can use to make things with a MakerBot. The standard one that we ship out with the MakerBots is white ABS plastic. This is really standard stuff. ABS is a type of plastic that Legos are made out of. And if you've ever stepped on a Lego, you know that the Lego wins. Here in this picture, we've got a dodecahedron, and we've got a twisted star box, and we've got some of the Stanford bunnies. This is off the first prototype, so they're a little rough, and they've got some overhangs. You can see they kind of flap down a little bit there. But ABS plastic, super great, super strong. One of my favorite tests is I actually take one of the pieces we have on hand, and I literally hand it to somebody and say, try and break this. It's hollow. You go for it. And then I take it, oh, you couldn't break it? Well, let's throw it down on the floor. And I throw it down on the floor as hard as I can. And
there's only one downside of ABS plastic, which doesn't come up often, but it does burn vigorously with intense heat.
So let's just show you how that works.
What if you take a blowtorch to one of these and melt it a little bit, honestly?
Let's find out.
Yes. Should I hold this or no? I'll hold it. I used to blow up these.
The original idea was to try and fix the overhangs, but
Poor little bunny smells really bad.
We can do better than this. Let's catch the whole thing.
Should we put it on the floor?
flames in slow-mo.
This is amazing. Where's my camera? My camera's in my bag. Oh my god, I love you guys. You're like two 14-year-olds, and it's a lot of fun.
Just another day at the office. No big deal. Oh, where did that go?
There we go.
Okay. Moving right along.
So, like Bre was saying, the MakerBot can handle a variety of different plastics. HDP was one of the plastics had been using for a while, but it does suffer from a few drawbacks that ABS does not. So HDP is high-density polyethylene, but most of you probably have a lot of experience with this plastic. It's the same thing that milk jugs are made out of. So the problem with HDP is that it has a higher shrinkage factor. So when it cools, it tends to warp, and the object will deform a little bit. So ABS doesn't really suffer from this. But the nice thing about HDP is it has a very low coefficient of friction. So if you want to build bearings or things that need to slide, then HDP is a good bet. It's also about, I don't know, 2/3 of the cost of ABS.
This is a material we're really excited about. Right now, actually, pellets of this are being made into 3mm filaments in
Ohio.
Yeah. And PLA stands for polylactic acid, which is actually derived from corn. Basically, they grow it in Nebraska. It's all made within 50 miles of the place where it's processed. They process it into little pellets, and then it goes to our place in Ohio, where they take the pellets and they make it into filament. It's green. It's not green in color, but it's green in that it's a natural material that, under the right circumstances, will biodegrade. And it also looks really cool. This is a ring. I actually brought this. Here, we can pass this around.
Heads up.
And of course, the first thing we thought was, oh my gosh, we have to put an LED in this.
And this is the latest plastic that we've gotten. This is black ABS, which we actually brought some samples of this today. Black ABS is exactly identical to regular ABS in every aspect, except it's black. And this, I don't know. I saw this, and it's just so beautiful. It's like the Black Stallion from that one book. What was it, The Black Stallion?
Black Stallion.
Okay, so it's good. I mean, we're all New Yorkers here, and so we know how awesome black is. Black is the new black, so it's good to have this color.
So let's break it down and tell you a little bit about the process of digital design, taking an object from your mind and making it a physical object. There's lots of different ways to get a digital design going. What you really need for this machine is an STL file. One of my favorite programs is something you've probably heard of. It's called Sketchup. And it's a pretty straightforward, easy to use 3D modeling application. And basically you download it. And I made this MakerBot watch in about 45 minutes of just playing around. I really didn't have that much experience with it. And just playing around with it, I was able to make this watch. There's some downsides to SketchUp in that right now it just outputs KMZ files, which is like a proprietary file, but there's hacks to get around that. And the advanced version, if you can pay for it, will output an OBJ file, which is very uniform. Somebody wants to put in a ticket to have them output STL files, I'd be totally into that.
Please. So the next step, once you generate a file like that, is a lot of 3D modeling programs are just for doing modeling. And 3D printing isn't like this big thing that everybody does yet. So you usually have to do a little bit of post-processing and cleanup to actually get it ready to print. So we like to do that in Blender, which is this really rad open source program, because it has a lot of powerful features for like removing duplicate vertices and recalculating normals and all these like weird little 3D modeling things that you have to do to get it to work. So you need a solid object. So if it has holes in it, it could still slice, but it might not. So your best bet is to get a solid 3D model that's completely manifold. And Blender is the tool that we like to use for that.
This is in vertice mode, so you can see all the points in the vertices as well, which is cool. So from Blender, you can output an STL file, and this brings it into, and then we bring it in, then we open up this program called Skeinforge, which is another open source program that is really cool. It takes an STL file and slices and dices it up so that it puts it into layers and then makes a toolpath. This is layer 15 of the watch, and you can see there's actually arrows on the thing. The red is going to happen first, and then it goes through the whole toolpath of where the robot is going to lay down material. You can change all sorts of settings on this. Skeinforge is if you want, you can spend.
There's a lot of configurations in there, but we ship a version of that just is ready to go out of the box. Which is
so you
really
basically
handy.
you load it up and it'll just work. That's the cool thing.
And last but not least, this is the program that we wrote to control the actual machine itself. So Skeinforge outputs a G-code file, which is like a very standard old school CNC format. They used to run these on like paper punch tapes. So it's been around forever, but it does the job. It's very simple. It's pretty much just a list of XYZ coordinates and a feed rate with some other extruder on, extruder off commands sprinkled in there for good measure. It has a little control panel, so you can log on to that and move the machine around yourself. And then when you're ready to go, you can just hit build, and then it'll run your G-code, and then your object will just magically appear in front of your eyes.
If any of you have used the Arduino environment or processing, this probably looks familiar.
Yeah, we forked their environment, ripped out all the guts that do microcontroller stuff, and put in new guts that does 3D printing.
So then you end up with a physical object. This is a watch that is accurate twice a day, and I spray painted it silver, and I'm pretty pleased with how it looks. And I get comments on it all the time. I was so excited I wanted a strap. I literally cut some parts off my backpack to make it happen.
Here's a close-up version.
Gives you an idea of kind of how a finished object looks.
There's also a bracelet above it that was 3D printed. And if you have a close eye in the background, there's pulleys that we've been printing to send out with the kits. So it's not just a rapid prototyper, it's a desktop factory.
So if you're into it and you have ATX and some tools, you can go and get the basic kit, $750.
Or if you don't want to mess around with getting the right tools and like, do I have a power supply? Do I have the right cables? We will sell you a kit that's everything you need to build it in a single box. And you just unbox it and you build it and you're good to go.
If you just want one and don't want to go through the hassle, you can make us spend the entire weekend making one for you, which is actually pretty fun.
Pretty fun, yeah. I mean, getting paid to build robots. Can't beat that.
And you can visit us at makerbot.com. Okay, it's been a pleasure talking to you. We're at the end of our presentation. Thank you very much.
If anyone has questions, there's a mic for them.
Yeah, feel free to ask us any questions you'd like.
I'm a Libra. I like long walks on the beach and robots.
Excellent. Is this on? Excellent. I don't know what the other open source ones are like, but I was wondering how that compares. And specifically, I remember a long time ago reading about printers that can print a dissolvable substrate so you can print more complicated shapes, and I was wondering about that.
As of right now, there's no open source 3D printer that has support material. It's literally one of the really hot topics that people are working on right now, because right now we're just printing with one material, which makes it really difficult to do overhang. So if you wanted to print a table, the legs would go fine, but then when you got to the table base, then things would sort of go not so good.
It would work, but it would kind of drip. It would kind of, not drip, but like go down a little bit for a few layers, then it would work itself out.
Yep.
Or printing upside down. There we go. But actually, yeah, to just mention, we've got frosting, and we're working on
hot glue and getting a Crayola crayon extruder for 64 colors of support material, and well, that's on we are
Version
on that.
2.
I have two questions. One is, what open source licenses do you use for the different parts of it? And the other one is, how far along are you on the self-replication? So what fraction or which components of this device can be made by it?
Sure. So to answer the first question, we use GPL on everything just by default because we feel like that was sort of the strongest and tried and true license. The tricky thing, the weird thing about that is that we're making physical designs and objects that are real. It's not just software, so which sort of falls under copyright because there's designs at the core of it, but physical objects fall under the realm of patents. And so we've been talking with a bunch of lawyers from the Free Software Foundation and just friends that do patent stuff, and it's basically nobody really knows what's up. So we thought it would be best just to go with the thing that's worked for everybody else, which is GPL, and it's so standard. And the thing we want to do is we want to protect the designs of technology so that they will remain free and open for everybody forever. The thing that would just break our hearts is if someone were to take this design and make it really cool and then say, we're not playing anymore, and not release those designs. So as long as they stay open and everybody can have access to them forever, then that's what we want to happen. I'm sorry, what was the second
other one
question?
was self-replication. So the cool thing is if you want to make a RepRap, we made it big enough that all the parts for a RepRap can be made on a MakerBot. So this is also called a rep strap in some circles, which means it can bootstrap a self-replicating robot. So you could do that right now.
On this machine itself, right now, these idler pulleys are 3D printed, as well as the ones down here. There's 4 of those pulleys right there. Our goal is to try and replace one part on here with a 3D printed part every batch. So the next batches, we're probably going to replace these little parts on the side. And like Bre was saying, we've been involved with RepRap for a long time, and it's just this really cool project. But the thing that's kind of held it back and just been this constant struggle is how do you work on a 3D printer if you don't have a 3D printer? Because you can, the people that started it have access to the big mainframe 3D printers, but nobody else in the community does. So it's really difficult to work on it. So it's kind of like writing a computer program without having a computer. So we wanted to make a computer that is in kit form that everybody can get, with the idea that as more and more people get this, there'll be more and more people who can actively contribute back to the RepRap project. And eventually, we'll have a really awesome design that's been iterated through dozens of times, and you just print out the parts, and you have a machine, and then your little MakerBot sits there continuing to build things, and then you have as many RepRap machines as you want. So yeah, self-replication for the win. More questions? Really? We're telling you that robots are going to take over the world.
Give an idea of performance. How long does it take to make it?
So the resolution on the XY axis is 0.1 millimeters, which is just about 300 dpi. The Z axis is much higher resolution than that because it's threaded rod based. So one revolution of the stepper moves at about 1.25 millimeters, and so divide that by 400, and then you're in the microns range. So, but the downside of that is it's slow. On the X and Y, we use belt drives, which means it can go really, really fast. We can move the XY axis at about 5,000 millimeters per minute, which I'm not sure what that unit means to anybody, but it can really whip around pretty quick. We print at around, I think we print around 3,000 millimeters per minute, and
So a dodecahedron takes about 18 minutes, and the little box you're holding in your hand, each part of that took like 17, right?
Yeah, the big one took 17 to build that. These little guys, these little miniature screw box thing, each one of these halves takes about 6 or 7 minutes to build.
We have to give credit to our friends Marius and Philip of the Meta Lab in Vienna, Austria. I infected them with the RepRap virus, getting them obsessed with 3D printing, and then they've gone on to actually do so many cool things. That's actually a dynamically generated object where you can choose how many points of a star you want, and then it depending on what you choose and how big you want it to be, it automatically goes zoop and creates a design. They just finished a plugin for a 3D modeling program called Art of Illusion, which is open source, that you can take your CAD files and say, hey, I have all these CAD files. I'd like to see 3D models of these parts in plywood, 5 millimeters thick, and at the touch of a button, all of a sudden you've got a 3D STL model that they just finished doing they're just working on a 3D model of taking the CAD files of this, and then boom, it exists. And then when you make a change in the CAD file, it changes the 3D model as well. So just got to give a shout out to them because they're badass. All right. Well,
wait, I've got one.
Oh, good.
Yes.
Every 2 months, without fail, I break my glasses and spend a fortune getting them fixed. On Thingiverse or any place else, is anyone looking at starting up a replacement parts repository? Let's say, like, if I describe well enough, this piece, I don't have to go spend a few $100. Is anybody looking at starting up a database of things like that?
I want that too.
That and the hinge for my GameCube LCD screen, the two things I break all the time.
Yes.
There's a few parts that, like, there's on Thingiverse, there's a dishwasher dial because somebody lost theirs and made a new one. And there's if you've ever had one of those old Nintendo games that was kind of like it was sort of like pre-LCD display. It's just like little shapes of people and they move like this. People always lose the battery compartment, and there's a battery compartment lid on there too. So the cool thing is as soon as somebody does upload a glass, the side of somebody's glasses, somebody will complain that they don't fit their glasses perfectly, and they'll do another one. And if we could, yes.
I have a feeling
let's put that on the agenda.
On the internet within a week.
On 3 times. I think I'm going to start this with describing.
But you can fix it with duct tape.
You guys have a 3D scanner here, right? That would make it a lot easier.
Anyone hiding a 3D scanner somewhere?
Okay, we're working on the open source 3D scanner now. There's on our wiki. There's a bunch of links that you can go and check out. We're not going to have time to get into it until June, so if you get ahead of us, just keep us updated. And because when we get a scanner that's open source that can sit right next to the MakerBot, then you're literally like, I need a new one of these in plastic. I'll just put it on the little turntable. It'll turn around, and then you just press print, and you've got a new one. That would be cool. What's that? Yeah, David Scanner's cool. I wish it was open source.
It's a cool project, but they started out open source, and then they said, we're taking our toys and going home, and now you have to pay for it, which is kind of a bummer.
What is it? It's 3D scanning. It's called 3D scanning. You need a webcam and a little quad little laser and this.
So the thing with 3D scanners is that it's pretty easy to hook up a webcam and a laser and a little table that moves. The hard part about 3D scanning is the math. And I wish we knew a place where there was people that were smart and love hard problems.
None of these here.
Is there any really good transparent material compatible with MakerBot?
So you could actually print out the lenses?
I mean, really the lenses on glasses in particular, the lenses are the things that are what you should be paying money for. But what turns out is you pay money for the frame. So if we can come up with a good frame design that you just put your lenses in, you might look like a dork for about 5 years until 3D printing really hits, and then...
No, I'll look like a dork until everyone else realizes how cool it is.
Exactly.
And all of a sudden cool.
Yes, sir.
Another thing a lot of people like modding are things like Playmobil or Legos or toy soldiers. Has anybody got anything on this score?
Yes.
Can I pull up a website here really quick? I didn't do it.
So the question for those was, what about Legos?
Oh, here we go. Parameterized Lego bricks. So this really is the power of parameterized modeling. So instead of having to sit here and add each little circle, these are the guys from Vienna who write this this plugin. And so they basically have a script where they say, I want a brick that is 2 by 7. And it generates the 2 by 7 model, and then they printed it out. And here is a bunch of Lego bricks, and they fit together, and everything just works really nice. Actually, Lego's really cool with this because as of right now, like the 3D printed Legos are not nearly as high quality as Lego. But the cool thing here is that you could make your own custom Legos. So who hasn't had a Lego piece that they're like, man, if only I had like this weird little piece that nobody makes.
A piece with my head on it.
Yeah, a piece with your head on it. And so you could 3D print that piece and then connect it to your normal Legos. And then Lego's probably going to sell more Legos because then more people are going to be interested in Legos. So
the 3D modeling community around Legos is also really obsessive. L-Draw is this community, and every time a new Lego piece comes out, there's an immense comment thread about the 3D model of the object because people are obsessive about it being right
Legos.
with the least amount of vertices and the best, accurate stuff. Go ahead and.
Well, since people don't trust how loud I can talk, I'm sorry I was late, but maybe you covered this. How well do you interoperate for some value of interoperate with other 3D printing technologies like 3D printers or other kind of stuff?
Yeah, the cool thing is that we to 3D print something with our machine. You just need an STL file, which is actually a older file. It stands for stereolithography. Really basic file. So if you want to take a file that works well on our machine and put it in some other machine, great, go for it. And in fact, we put the idea here is like here's the downloads. You can see they have an Art of Illusion file. They have STL files, and then they just there's all sorts of stuff that basically we want to be as open and compatible as possible.
Cool.
So like when the Next Engine is a scanner that came out that's about $3,000, we called them up and we were like, hey, we want to make sure that our machine can print out objects that your machine scans. You want to send us one? And they were like, no, but here's our entire repository of objects that you can test it out on. And works
Nice
fine.
try.
We try.
Are there conductive materials that could be used to create composites that could have some sort of electric or electronic capability?
yeah, that's another hot area of research in open source 3D printing. That's one that the RepRap project has been just really interested in from day one, because then not only can you print plastic things, but you could print things with integrated circuits that are three-dimensional, and then you could really just print a robot that could just drive itself off the build platform instead of having to be put together. There's been some limited success with just printing with solder directly, but that brings its own problems. There's a few polymers, like a few people are working with an epoxy that has copper particles in it. And the cool thing about that is you lay down this epoxy, and then before it has a chance to harden, all the copper sort of precipitates out or falls down to the bottom and forms a track. The problem with these is that they're not solid strips of metal, so the resistance is fairly high compared to just like a standard copper track. So, and of course it's all open source, so if you have that winning idea, if you give it to the community will give back to you. So.
Hey, do we get to see your MakerBot actually make anything?
Yeah, absolutely. We were printing before the talk, and I think we're going to start printing after the talk and skip lunch. I don't know. I would be fine skipping lunch, but.
What we'll do is we'll start it up before we leave, and then we'll go get lunch. We actually got a comment recently on a blog that because we gave a presentation, we set it up, and then we both walked away, and we regularly just start this thing up and then surf the net. I mean,
I start prints and then go home because I've logged a few hundred prints on this machine in particular, and it just works, and it's so nice.
Hey, what stops you from making just a much bigger 3D printer? Like, what are the limiting factors?
Okay, I have a vision for this. I want 20 foot by 20 foot. Well, probably let's start with 8 foot by 8 foot because that's easy to get lumber. I want an 8 foot by 8 foot by 8 foot platform that will use construction foam, and I want to mount this on top of a building and make giant spheres out of that construction spray foam And then when each one is done, I want to roll it off the building, smash it on the ground, and start building another one. That's my vision.
So on the more practical side of things, so this guy, first of all, it's nice. It's portable. You can carry it around with you. It fits in a case. It'll sit on your desk. The RepRap machine is about this big by this big, so it's a little bit more bulky, but the real fundamental reason is that it actually takes a fair amount of time to build something. So if you were to build something that was fairly solid and was about the maximum size of the build area, it would take you many hours to build that. So if you made it much bigger, you would just have all this wasted space. And
you could use the motherboard, though, and hook it up to a machine that would build houses or lay down concrete if you wanted to go that way.
Yep. Also, our laser cutter is 12 by 24, but I mean that...
And that's actually, we're actually at our maximum. This is the biggest robot we can build until we get a new laser cutter. So, cool.